equivalent to decay.
Thank you, Sven. Yeah, indeed. How could we, or how do I think that we could accelerate application of the European health data space for the citizens, and for the citizens now directly, and more important for the research, and also for the citizens later for a longer life. But I will begin with a few facts about longevity. Most of you know, but it is an always useful reminder that today, like every day, about 120,000 people in the world will die of diseases related to old age. So this is in our rich countries, about 90% of deaths in the world, about 70% of all deaths together. And even in the poorest countries, some people say, yeah, but you have to care about poorest country first and not about aging. They are right that we have to care about the poorest country, but it's even there 50% or more. Like you know, life expectancy is rising regularly in the world, in Europe and in Belgium, but it was decreasing recently due to COVID, and the situation is about the same. So this is from 1950. In Belgium, you see this is very regular. And there was the COVID was the first time in human history. Sorry, it was the first time since World War II. So in our life, that life expectancy was globally decreasing in the world, but now the situation is going better. So when we die of diseases related to old age, these are all causes of deaths. It's mostly cardiovascular diseases, cancers, neurodegenerative diseases, and other non-communicable diseases. But one important point is, even if we die of, let's say, common diseases or common causes who are not directly related to old age, it's still because of the old age that in place we are dying of this, and not going well after a while. So infectious disease like flu, tuberculosis, and COVID, of course, but falls. So if you fall in your house, and you are 20, 30, your probability to die of it is about 0, except if you are very unlucky. If you are above 80, your probability to die of this is more than 10%, 20% even. You know, probably most of you, that actually we progress for many, many things, but we do not progress concerning the maximal lifespan. We do not progress at all since 1997, when Jeanne Calment died when she was 122 years. Well, I know there are people thinking that it's not true, but let's go that outside. Even if it was not Jeanne Calment, it was another other person who was 120. And the oldest woman in the world today is not 116. She turned 117 recently. I forgot to actualize this slide. And the oldest man in the world is not even 114. It was one guy living in Venezuela, but it's 112. So it's even less. So when I say we don't progress, it's really sadly spectacular. Like I said already, there was a decrease of life expectancy, not anymore maximal life expectancy, but average life expectancy during the COVID crisis. And this is spectacular because it is the first time, maybe in history, or at least of the last 2 centuries, where you have technological global progress continuing at the world level, but you have people living shorter lives and probably also less happy lives. I think that it is very probably possible to find a treatment against aging within 15 to 30 years, but it will be complicated and expensive, except if AI is changing all that very, very, very fast, AGI, but that's maybe another discussion, even if David will probably approach that soon. Now, facts about big data for health, especially at the European level later. So first, it is often said, but I never found a very precise reference, but it is often said that 30% of big data is health big data. So a very, very, very big part. There is also, of course, everything what is in clinics, your medical doctor and so on. There is scientific literature. There is, and this is a big part of this big data, what is in your smartphone. Okay. And you have, last time I saw, like more than 300,000 healthcare apps, but as far as I know, there is not one largely used public space to share personal health data to facilitate medical research. I mean, freely. It is the questions that Anton asked a few times. Well, there's about why can I not, well, in very short, why can I not share my health data? So there is no place organized for this. And so the important thing is that the problem is not that we don't have enough health data. The problem is that we don't have enough access to health data. So the central question is how to share health data, to know which human clinical trials should be started immediately for longevity, which existing drugs, for small longevity progress, and also to prepare breakthroughs. Now, the legal and even more important, the de facto situation in Europe, I think that you can summarize this as, but if you disagree, tell me. So first, you are theoretically free to share, but actually you are obliged to share with private companies and with public entities if you want to use their services. And these institutions, they will sell the data or make it available, but only with many restrictions. So in theory, yeah, you give, or sometimes you give informed consent, but of course you still don't have a judge choice. You know, you cannot go to your medical doctor and say, oh, don't take any notes, or maybe your medical doctor, but certainly not in a clinic. You are not allowed to share most of your data for science, because in no country with the tools, at least in no country of the European Union, in the tools that are existing now, you are allowed to share it easily with scientists. Even if you decide to do it, scientists will have problems if they use your data. I will come for one very spectacular example in a few slides, maybe the next. And even if scientists decide to use your data, they will probably not be able to have their finding published because of ethical questions. Yeah, and so this is the next slide. This is Beata Halassi. She was in the press recently because she discovered a way to cure her own cancer, and she was using the products that she discovered on herself. And after that, she wanted to publish that, and it was quite complicated for her to publish. And there is, okay, that's because, let's say, so-called ethical people are afraid that other people could test on themselves, like if it was especially totally immoral. Now, coming to the main part of my intervention is what can we do for a few possible open solutions, for a few progress. First, in theory, the best place would be the World Health Organization, because at the world level, it's there that they have access to the most organizations, people, and so on. But yeah, no. Maybe Huguette, who is the last speaker, will speak about, well, she will speak about the World Health Organization and maybe about some ways to share, but it's very small at the moment. So pragmatically, the real place where this is possible is the European Union. So one of the reasons, one of the problems is people are really very often, especially in Europe and even more in countries like Germany, afraid to share their health data. So of course, health data is sensitive. but it's far less sensitive than your political life, than your sex life, than most of your private life, and it would be less risky if it was a public system where health data would not be to be sold. You know, one of the main reasons, not the only one, but one of the main reasons people are afraid, that's because they are afraid that the health data is used with an insurance company or is used to sell something more expensive because they know that you are especially interested in this medical problem. But okay, if it was prohibited to sell it, I think the situation would be with far less risk. What I hope, but this is another question, and we didn't speak. I think we didn't speak about this, but there is the situation concerning patent. You know, some people say, yeah, we have the Ehrum's law. The Ehrum's law is the fact that there are less. So the Moore's law is the law. It's not the law. That we have an exponential velocity acceleration of, let's say, all capacity. The Moore's law, the Ehrum's law is the law, but no, one more time, it's not really a law, but saying that the number of scientific discoveries is getting slow and getting more expensive. So one of the reasons is the fact that many drug companies, many medical companies, they absolutely want to have patent. They also want to have public money. And I think that to facilitate sharing of data, at least there should be no patent when there is public money, and at least there should be the obligation to publish negative results. Because when a big drug company is testing a drug and seeing that it's not working, well, they don't have any incentive to publish it. Even sometimes they have an incentive not to publish it. And so it should be compulsory. It is compulsory in some cases, or particularly, but not always. And also, with research outside patentable fields is a lot more difficult. The example is the fact that the so-called TAME study, that's a study on metformin. Metformin is a product who is maybe probably somewhere between making a longer life possible for most humans. This study on metformin, the so-called TAME study, is supposed to happen since at least 5 to 10 years and didn't happen. No, that's because metformin is the patent is finished, let's say, how do you say that, expired many years ago. Okay, we should constantly remind, like I think it was a speaker who said that, yeah, it was Karina Dantas who was saying that as the first speaker, constantly remind that most people are willing to share health data for scientific and medical goals. Each time there are studies about that, it's very clear. Sometimes people are afraid to share with pharmacists, but for the rest, no problem. There is a large consensus concerning this. In the European data space legislation, there is the principle of what's sometimes called altruist databases. So it means that people having the health data could not have a commercial goal. So it is less worrying if it is altruist. There could be more trust if there is no financial goal. And once again, less risk if there is less to sell. So if it is more complicated to sell the data. Many people here and in other places speak a lot about it's more interoperability, interconnectivity of databases, but and it has to have a good interconnectivity. You need a good interoperability. So it must be between states, between medical actors, between times also, that the new software is not making access to the old software impossible. And yeah, between practitioners and between citizens. I forgot to write it. The problem is the crazy competitive. I just took a picture of one slide of one conference about the situation in Flanders. But you see, there are texts I even don't know about what it is precisely, but you have at least the legislation, the laws concerning the medical devices, who is very complicated. You have, of course, the EHDS, European Health Data Space. You have a Cyber Resilience Act that is for security problems, and of course also a big one, a very big one, is AI Act. But you have also many others. So the laws are incredibly complicated. And to take the EHDS, the fact that it's at the moment not yet a text who is final and published is because they try to translate it correctly, but that's not the first problem. I thought it was the first problem, but they try to make it compatible with all other rules. And yeah, for me, I mean, it will be impossible, and there will be probably people going into courts after. But okay, crazy complexity one. Crazy complexity, this is outside of the medical field, but I like to show you this page. This is page 127,571 of the official journal of Belgium. And why this page? Because this year it was breaking the absolute record of last year. And this year it will be probably something like 140,000 pages of laws on the laws, regulations, and so on, only at the Belgian level. And I can assure you, nobody is reading. Probably, literally, no, certainly nobody is reading this journal entirely, because if you have no time, you would have more than 24 hours, more than 24 hours a day are necessary to read everything. And probably such a page, nobody reads it, you know, literally. Okay, that's also a picture. Sorry, I had no time, but that's one of the timelines. But you see here, actually, this was already, I mean, yeah, you see here, they write 2025 for the general, but when Shivani was for first meeting concerning the EHDS, you told me what they were more saying 24, I think, and so it will be 25, and that is 25 now, if everything is going okay. And 25 no, this means that the last aspects will be for 2036. So, yeah, so slow. There is one positive aspect, is that you have there the deadlines, the maximum, but you can have institutions who decide to go already, to apply already what is compulsory now and not to it. I think that we have a duty to help. We have a moral duty, so to make this possible, because it will save lives. We have an ethical duty for the same reason. Sometimes you can consider that you have, even at least in countries like Belgium, France, and I think Germany, if it is possible to save lives, but you have to do it. It's a legal duty. It's a crime not to help. So, of course, for this, we should use artificial intelligence, and maybe, but this is a large, complicated discussion outside of the scope, AGI. artificial general intelligence, because AGI will not suffer from what's called Aubrey de Grey, one of the most well-known longevists in the world, calls the death trance or mortality salience of terror management theory. The fact that because we know that we are going to die of old age if we cannot escape, if we can escape other causes of death, and because this is awful, many people prefer not to think about it, or prefer to say, yeah, it's a good thing to die of old age. Okay, because also other priorities than medical fields are, than medical and research for longevity fields are more dangerous. So less existential risk if we use this for AGI. And of course, at the moment, AGI, at the moment, artificial intelligence is still better combined with human intelligence, even if well, there are people saying it's not anymore the case, but it seems that it's even still the case in most medical studies, than if you have an artificial intelligence working alone. It is less good than if you have an artificial intelligence working with scientists, medical doctors, and so on. Okay, and then just once we have this health data, of course, it will be for clinical test for longevity, and we need simplification. Because at the moment we have more scientists than ever in the history of humanity, but we have also more bureaucracy than ever in the history of humanity. And it is the cost now for new drug is sometimes they say 1 billion, sometimes they even say 2 billion to test for a new drug. It is crazy, and with the progress, Jan and others, you spoke about that, with progress of artificial intelligence, sometimes tests are not even necessary anymore. So the first cause of bureaucracy is the heavy regulation in US and in Europe, but there are other causes. So we need less bureaucratic and faster system at the European level, of course, ideally at the world level. So an average IRB, that is an ethical authorization in the US, it takes many months, and even worse, sometimes there is no ethical authorization. An authorization is mostly only valid in one place. For example, in Germany, I think it's only valid even in one land, not in in Belgium. It's the whole country, but still, it's a small country. We need to test on animals living a very short life, like this fish, Notobranchius drosophil, the fly drosophil C. elegans of Sven, but also for animals living very long lives, like the naked mole rats. We need double-blind trials with people wanting to have the best treatment. Okay, with people who are old enough, well-informed enough, and in good health at the European level, because 120 people a day, there are 120,000 people a day to save. We need a global project, like some people say a Manhattan project, but Manhattan it's a little bit too military. NASA project, I don't know the name, but anyway, a global project. So this is all except for the conclusion. So what we need, in very short, reliable shared big health data that we can curate and analyze with artificial intelligence and human intelligence, fast clinical tests, of course, more research, and like something making the link to all those aspects, we need a sense of urgency. We all know that we are going to die of old age if there is no solution, and if we can escape other causes of death, but it's kind of something coming slow, so we don't feel how urgent it is for so many people. So, in a few words, what HEALS and International Longevity Alliance and others say, you can syntheticize like create a system trusted by citizens, managed by, well, there not everybody agree, managed by a public institution or non-profit organization, where by default opt-out, I spoke about opt-out at the end of the morning. All health data, anonymized or pseudonymized, can be used for scientific research and not for any other use. And of course, the goal is to start a clinical test. And of course, the final goal is to enable everyone wishing it, not going to be compulsory, to live a radically longer and healthier life. Thank you. Now, I think that there is plenty of time. I don't know how long I was speaking, but yeah. There is time for questions now, at the end of the day, and by email. Thank you. Jan.
I also think that more funding for fundamental R&D will be also needed. Where do you think this fund should be coming from?
Well, that's, yeah, I was suppressing this slide, you know, because I thought I will not speak about money, but you're totally right. I say very often that I don't understand how it is possible that the Life Expectancy Velocity Foundation doesn't get the money for the second phase of test on mice. It's a small amount of money. I don't understand how it is possible that the TAPE study doesn't receive the money. And I don't understand why there is at the moment no public organization who has explicitly as a goal to